This content is produced by PASS, the CSLB, an independent audio-first study companion for busy California B General candidates. I build these lessons from official CSLB study guide topics and reputable source-backed California materials so you can study on the go. This is exam prep reinforcement, not legal, professional, engineering, or job-specific advice. Exam content is set by PSI and the CSLB and may change, so always verify current requirements against official CSLB materials. No exam outcome is guaranteed. Now let's get into it. The most important stair principle is simple. A flight has to feel repetitive under a person's feet. The individual dimensions matter, but uniformity is what keeps one step from surprising the body. A stair can look clean from across the room and still fail a careful field check because one riser is too tall, one tread is too shallow, or the bottom step changed after finish. Materials were added. I want you to separate 3 questions every time you inspect or supervise stairs. First, what code environment controls this stair? Residential, commercial, or temporary construction access? Second, what triggers the safety component? The number of risers or the height of the open drop? Third, did the finished materials preserve the intended geometry? Those distinctions keep similar numbers from getting mixed together. For a standard residential stair governed by the California Residential Code, the maximum riser height is 7 3/4 inches. The minimum tread depth is 10 inches. I remember that pair as a residential stair being a 1/4 inch shy of an 8-inch rise paired with a 10-inch tread. Tread depth is not simply the full width of the board. It is measured horizontally between the vertical planes of adjacent tread nosings. That matters when a tread has an overhanging nosing. The overhang may increase the physical board width, but it does not automatically increase the code measurement between adjacent nosings. For a commercial stair governed by the California Building Code, the basic pair changes. The maximum riser is 7 inches, and the minimum tread is 11 inches. The commercial profile is therefore shallower and deeper than the residential profile. Looking at this comparison, I want you to lock in the boundary rather than memorize one floating pair of numbers. Residential is 7 3/4 by 10. Commercial is 7 by 11. Both permanent systems use the same maximum variation within a flight. 3/8 of an inch between the largest and smallest riser, and 3/8 of an inch between the deepest and shallowest tread. A common mistake is carrying the commercial 7 by 11 pair into a residential layout, or carrying the residential pair into a commercial egress stair. The numbers are close enough to feel familiar, which is exactly why the governing code has to be identified before layout begins. Residential geometry also includes the clear path around the steps. The stair must provide at least 36 inches of clear width above the permitted handrail height. The required headroom is at least 6 feet 8 inches, measured vertically from the sloped line that connects the tread nosings to the lowest overhead obstruction. I want you to picture the nosings as creating an imaginary incline. Headroom follows that incline. It is not measured from one convenient tread to one convenient ceiling point and then assumed to work everywhere. A soffit, beam, or floor edge can create a local pinch point that controls the inspection result. A single residential flight cannot exceed 12 feet 7 inches of vertical rise without a landing breaking the flight. A floor or landing is required at the top and bottom of each flight. The landing has to serve the full stair width, and for a standard straight run, the depth in the direction of travel is at least 36 inches. This reference groups the spatial checks that are easy to miss when attention stays on the stringer cuts. I check width, headroom, total flight rise, and both landing transitions as separate items. A stair can have perfect risers and treads while still losing required clearance or landing space because framing, drywall, finished flooring, or a door condition changed around it. The practical supervision point is coordination. The stair opening, floor framing, wall finish, ceiling finish, and landing surface all affect the final measurement. A rough opening that barely works before finishes can become too tight after gypsum board, trim, flooring, or a soffit is installed. Uniformity deserves special attention because a small layout error can repeat through the entire flight or show up at only one end. The maximum permanent variation is 3/8 of an inch within one flight. That limit applies to riser height and tread depth. Suppose a crew lays out every rough riser consistently, but forgets to account for the finished tread at the bottom. Once the treads are installed, the bottom rise can become taller than the interior rises. The usual layout correction is called dropping the stringer. The bottom of the stringer is shortened by the exact thickness of the finished tread, so the installed tread does not add an extra amount to the first finished rise. The key word is finished. I do not compare a rough stair to a finished stair and assume the numbers will remain the same. I coordinate the thickness of the stair treads, the finished floor at the lower landing, and the finished surface at the upper landing. Each layer changes where the foot actually starts and where it lands. Here is the consequence chain. A missed finish thickness changes one end riser. That end riser may exceed the variation allowed within the flight. The stair may then require adjustment or rework after expensive finish material has already been installed. The problem begins as a layout detail, but it becomes a schedule and quality control problem. I also want you to remember that open rises have an opening limit. On stairs rising more than 30 inches, the opening must not allow a 4-inch diameter sphere to pass. That is a separate check from riser height. One controls the stepping geometry and the other controls the size of the opening. A handrail and a guard are not interchangeable terms. A handrail gives the user a graspable guide while ascending or descending. A guard protects an open edge where a person could fall to a lower level. For a residential stairway with 4 or more risers, a handrail is required on at least one side. The handrail height is between 34 inches and 38 inches, measured vertically from the sloped line connecting the tread nosings. That trigger is based on the number of risers, not the total drop beside the stair. A short stair can require a handrail even when no guard is required. I keep that distinction simple. Riser count triggers the handrail, open edge elevation triggers the guard. Graspability also matters. A circular Type 1 handrail has an outside diameter between 1 and 1/4 inches and 2 inches. A larger Type 2 profile with a perimeter greater than 6 and 1/4 inches needs the specified graspable finger recess on both sides. A decorative top rail is not automatically a compliant handrail just because a hand can touch it. A residential guard is required along an open-sided walking surface when that surface is more than 30 inches above the floor or grade below. On residential decks, balconies, and elevated landings in California, the minimum guard height is 42 inches. That 42-inch number is a California point worth isolating. National material often repeats a 36-inch residential guard height, but the California source material for this lesson requires 42 inches at those horizontal elevated surfaces. I do not import the national number into a California field check. The open side of a stair has a different height rule. A residential stair guard can be at least 34 inches high. When the top of that stair guard also serves as the handrail, the combined top has to stay between 34 inches and 38 inches. That range satisfies the stair guard condition while keeping the graspable surface at handrail height. This table separates the trigger from the dimension. 4 or more risers triggers the residential handrail. A drop greater than 30 inches triggers the residential guard at an open walking surface. The standard deck, balcony, or landing guard is 42 inches high. The stair guard is at least 34 inches, and a combined stair guard and handrail stays between 34 and 38 inches. The opening limits also change by location. Standard guard infill must block a 4-inch diameter sphere. The open side of a stair must block a 4 3/8 inch sphere. The triangular opening formed by the tread, riser, and bottom rail must block a 6-inch sphere. I treat those as 3 separate inspection locations, not one universal spacing number. The ordinary guard field uses 4 inches. The open stair side uses 4 3/8 inches. The tread riser triangle uses 6 inches. The geometry of the location tells you which limit applies. Temporary construction stairs are governed by California occupational safety and health requirements rather than the final residential or commercial stair geometry alone. The workstage changes the rule set. Temporary construction stairs must be at least 24 inches wide. They need landings at every 12 feet of vertical rise. Their maximum variation in riser height or tread depth is 1/4 inch within a flight, which is tighter than the 3/8 inch variation permitted for permanent stairs. That difference matters because a contractor can correctly remember the permanent tolerance and still apply it to the wrong stage of work. I use two mental folders. Finished permanent stairs go in the Title 24 folder. Temporary worker access goes in the Title 8 folder. The dimensions are related, but they are not interchangeable. Wood framing also has a sequencing requirement. The stairway to a second or higher floor must be completed before studs are raised to support the next higher floor. This is a supervision decision, not just a carpenter's layout issue. Access has to be established before the next elevated work area is built out. This checklist places permanent and temporary requirements side by side. Permanent residential stairs allow up to 3/8 inch of variation. Temporary construction stairs allow only 1/4 inch. Temporary stairs also have the 24-inch minimum width and a landing at every 12 feet of vertical rise. In wood framing, the stair must be completed before the next higher floor's supporting studs are raised. The sequence tells me what to verify before crews move upward. I do not wait for finished work to discover that the access route was never completed or that temporary geometry drifted beyond the allowed tolerance. The stringer itself still has to remain structurally sound after layout. A cut stringer acts like an inclined beam with repeated notches removed for treads and risers. After those cuts, at least 5 inches of continuous throat depth should remain along the uncut portion. The throat is the narrow solid wood left between the inside corner of the notch and the bottom edge of the stringer. If that section becomes too thin, the notches remove too much of the member. The practical field choice is not to force a layout onto undersized material or deepen cuts until the numbers fit. The stringer size, total rise, total run, and supported design all have to work together. The stair tread load check is also substantial. The source material requires a tread to support a uniformly distributed live load of 40 pounds per square foot or a 300-pound concentrated load on a 4 square inch area, whichever produces the greater stress. That reminder keeps the lesson grounded in structure. A stair is not only a set of dimensions, it is a load-carrying system used repeatedly under moving weight. For supervision, I combine geometry and structure in one final pass. I verify the governing code, the rise and tread pair, the within-flight variation, the clear width, headroom, landings, handrail trigger, guard trigger, opening limits, temporary access rules, and remaining stringer throat. I do not assume one successful measurement proves the whole stair is ready. Here is the clean memory connection. Residential geometry is 7 3/4 by 10. Commercial geometry is 7 by 11. Permanent variation is 3/8. Temporary variation is 1/4. 4 risers trigger a residential handrail. A drop greater than 30 inches triggers a guard. Horizontal residential guards in California are 42 inches. A stair guard starts at 34 inches, and a combined stair guard and handrail stays between 34 and 38 inches. The central idea is not a pile of unrelated numbers. Each number answers a different field question. What geometry controls the steps? How uniform is the flight? Is the user holding a handrail being protected by a guard or both? Is the stair permanent or temporary? Did finished materials preserve the planned rise? Once those questions stay separate, the numbers become much easier to retrieve. There is an audio practice quiz for this specific episode on stair geometry, guards, handrails, and landings. It is audio-based. I read the questions aloud and you answer by tapping, so it works for people studying while driving, working, or otherwise on the go. Go to the description below this video. You will see a link that says Pass the CSLB. Tap it. It will take you straight there. Comment below with any questions about what I covered. Subscribe so I can help you stay on track through every episode until you get your license. I know this study time has to fit around real work and real responsibilities, and I want each episode to move you one clear step closer.